All right, welcome back, everybody. We're going to be focusing right now on the practice test for our graphing quadratics chapter. So just like always, I'm going to go through the practice test. I want you guys to try to take away as many skills and strategies as you can to help you prepare for that test that you guys are going to be taking in here tomorrow. So looking over here at problem number 1, it says choose the graph showing the following features. We are looking for a graph that is concave down with a vertex at -1, 4. Now, if I'm looking at this problem, one of the first things I think I'm going to look for is this concave down part. It should be relatively easy to identify the graphs that are concave down, and that's going to kind of limit our choices. Well, look at this. The only graph we have here, this one is concave up, this one is concave up, and this one is concave up, which means the only graph that is concave down would be this one because it's flipped upside down, right? So let's just verify though. Do we still see that the vertex is at -1, 4? Well, we went back 1, up 4. There's our vertex. Yeah, it looks like we do. So this would be the problem that I would choose for the first one. Nice job. And like I said, just using your information kind of smartly, in that one, just looking at the concave down piece allowed us to eliminate all the options except for the right one. Here's another one. It says, find a parabola with a line of symmetry at x equals -1 and a y-intercept at -1.5. I'm going to start by looking for this y-intercept at -1.5. So looking at our graph over here, it looks like, well, let's just start right here. It looks like the y-intercept for this one is at 3, so that's probably not the one we want. Over here, it looks like the y-intercept that we have is at -3, right? The y-intercept, remember, is that point, so probably not this graph. Let's look at this one. Well, this one looks like our y-intercept is at -1.5, which is what we were being asked to find, so that's looking pretty good. Let's double check this part. If we have a line of symmetry at -1, that means I should be able to draw a vertical line that comes through at -1, and it should hit my vertex, which this one does. So it looks like we do have the correct graph right here, and we were able to find it. So this would be our answer to that second one. So not so bad, right? Those are those easy level questions that we definitely expect you to be able to get at this point in time. Now we're going to get to kind of some harder problems. Same standard though. There's really only one standard that's being assessed on this test, so there's really only one part. So looking at this test, it says identify the features of the graph. Now when you're looking at this, the graph has already been provided for you, so you can kind of switch between looking at the actual equation and looking at the graph. My lights just shut off. Hold on. There we go. So looking at this one, we can see that this graph is upside down, right? It opens downwards. So that means that our concavity will be concave down. Looking at this, we want to identify our y-intercept. It looks like this one wants us to give our y-intercept as just a point or as just the number. So coming over here, for our y-intercept, remember, you're just looking to see where does the function cross the green line. And it looks like we cross right here at the point -5. So if that's the case, then we will say that our y-intercept is -5. Now, for the vertex in this problem, we just need to identify either the high point or the low point. Hopefully you can put your finger on the vertex and say that the vertex is right here, and that's exactly where it is. It looks like this vertex has an x value of 2 and a y value, since we're down 1, of -1. Remember, when we list these, we always list the x value first and the y value second. Be careful you don't mess those up and put those in a different order. So we can put a 2 here and a -1 here. Now, the last thing we're being asked is, does this graph have a maximum or a minimum? Well, that's relatively easy to answer. If you look at your vertex is always the point that that's referring to. You just want to say, is that a high point or a low point for that parabola? And in this situation, it's a high point, which means we will have a maximum. So that will be our correct answer. Not so bad. Like I said, I know you guys can do this stuff. Here's our next one. It says identify the features of the graph. So again, we're given the function and we're given our graph. Now, just looking at the graph here, that's hard to read. I'm not going to be able to just guess and pick numbers off of there and get those correctly. And that's actually what this hint says over here. The graph is difficult to read. Try to calculate. Now, some of the stuff we're still going to be able to look at the graph and be able to tell. Other stuff we're not going to be able to. So, Looking at this, first off, we can see that this graph opens upwards here. So if it opens upwards, we know that we are going to say concave up. Remember, the concavity is directly related to your A value over here. So if your A value is positive, that's how we know we're also going to be concave up. As for our y-intercept, there's a couple of ways we can do this. In this one, it actually looks like the y-intercept is at a nice point here. 1, 2, 3. So it looks like our y-intercept is at 3. Now, remember, it did give us a hint that said the graph's difficult to read. Try to calculate. If you are struggling to find the y-intercept or you want to verify, remember, you can always look at your c value over here. Your c value is the exact same as the y-intercept. So it looks like, since I know that that is 3 and my intuition by looking at the graph told me it was 3, that it probably is 3 and we can put that there. Now, the x-intercepts, I don't have a clue as to where those are right now. So we are going to have to calculate to find those. Line of symmetry looks pretty tough here too. So let's start by finding our x-intercepts. Remember, to find our x-intercepts, you want to take the given function and factor it. This one looks like it's a tougher factoring problem, but definitely doable. So we have 2x to the second, let me double check, minus 5x plus 3. So when we come over here and want to factor this thing, you're going to make your x. Remember, to get the top number, you want to multiply 2 times 3, that's going to give us 6, and negative 5 is going to go on the bottom. Now this is going to be 2x over and 2x over. And then you're just looking for the two numbers that multiply to give us a 6, that add to give us a negative 5. Now, two numbers that multiply to give us 6, that add to give us a negative 5 would be, oh, that's a tough one. Nope. Negative 3 and a negative 2. Double check that. Negative 3 times negative 2, that's a positive 6. Negative 3 plus negative 2 would be a negative 5. Now, remember when we write these out, our first factor will be 2x minus 3. Looking at the second one, it looks like this reduces. 2 and 2, right, becomes 1x minus 1. So I'm going to get just x minus 1, or 1x minus 1 if you like that better. Now, anytime you're looking to find the intercepts, this is always set equal to 0. So if this is set equal to 0 right here, then what you want to do is use your zero product property to solve. So what we're going to do is we're going to take this first part, 2x minus 3, and we're going to say equals 0. And then we're going to take the second part, 1x minus 1, and set it equal to 0. And then we just solve. So solving this first one, you would start by adding 3. You would get 2x is equal to 3. And then, of course, divide by 2, divide by 2. X is equal to 3 halves, or it could be possibly 1.5, depending on what Schoology has for you to pick, right? Because those two things are equal. On the other one, add 1 and add 1, and you're going to get 1x is the same as just x, is equal to 1. So we get our two answers right here. So our x-intercepts will be x equals 1, and x equals, let's just pretend it was a decimal that Schoology gives us, 1.5. Nice job. The last part here is asking us to find our line of symmetry. Now, in order to find the line of symmetry, if you can't easily tell where your vertex is at, remember, we have this formula to help us out. Negative b over 2a. That's how we find the vertex, but remember, when we first use this formula, it gives us the line of symmetry. So negative b over 2a. So I'm going to take my values. Looks like our b value was a negative 5, so I'm going to have a negative 5, right, because that's the negative b part, over 2 times a, and a is just 2. So solving this, negative 5, two negatives always make a positive. 2 times 2 is 4. 5 divided by 4 is 1.25. So that means our our line of symmetry is going to be x is equal to 1.25. And remember, that just means that a little over at 1 1/4 here, if I draw my vertical line, I should go right through my vertex, and it looks like I surely do right there. So it feels like we did this correct. Great. I think we got one more problem here. Yep, another selecting one. So we want to select the correct graph here. Now in this one, they don't give us the graph at all, and we are also asked to identify the key features of this graph. So let's see what we can do. Looking at this first one, if you check this number, and this number is positive, which 1/2 is positive, there's no negative sign in front, that means that our concavity is going to be concave up. Now, if we're trying to select the graph, let's get rid of any that aren't concave up. It looks like this one was concave down, so we don't need to even think about that graph anymore. Second thing we want to look for is our y-intercept. Now, the only thing we have to go off of is our graph, so we need to use our knowledge of the fact that this number is the y-intercept. So since that is a positive 2, that means y equals 2 will be our y-intercept. So now let's go to our graph and look for all the y-intercepts of 2. Well, it looks like only this graph has a y-intercept of 2. This one had a y-intercept of -1. This one had a y-intercept of a positive 4, which means it's definitely not this graph, and it's definitely not this graph. So the graph we must be talking about is actually this one right here. Oh, hold on. I want to make sure I get this right. So let's do this. Copy that. So I'm going to put my graph right here so we have it to look at. Wonderful. Now it's asking us for our x-intercept. At this point, we've already identified which graph it is, so we can actually come over here and just try to pick off that intercept off the graph. It looks like this one happened at a nice point. X equals 2 would be that intercept. Now this graph only had one intercept because it only crossed the x-axis one time. And the last part is the vertex. Well, looking at this, the vertex is the same as that x-intercept, so we just need to give the point. So it looks like x equals 2, y equals 0. Now, just in case, if you were given a graph where you weren't able to figure out the y-intercept that easily, then don't forget you can always just come over here and solve this. So if you wanted to solve this, 1/2 x to the second power, sorry, I'm just want to get this, minus 2x plus 2, minus 2x plus 2. Now, off the bat, I look at this and say this is a hard problem to solve because factoring is not going to be an option. So remember, if factoring is not an option, your other option is always to use the quadratic formula. So remember, that's negative b, so I'm going to have a negative 2 plus or minus the square root of -2 squared minus 4 times a, which is 1/2, times c, which is 2, all over 2 times a -2. Now, at this point, you just need to go through and simplify. -2 gives us a positive 2. Plus or minus, on the bottom, 2 times -2 is a -4. Now, the inside of the square root is always the hardest. So let's grab our calculator and let's type this out. So we're going to have our -2 to the second power minus 4 times parenthesis 1 divided by 2 times 2. And our calculator does the work and comes out with 0. So this is the square root of 0. And of course, we should simplify the square root of 0 if we can. So second square root of 0, oh my gosh, the square root of 0 is 0. So that basically goes away. And this is what we're left with. We're left with our two situations. 2 plus 0, which is 2, divided by a -4, or 2 minus 0, which is still 2, divided by a -4. Now, one thing that's kind of unique, and I know it's been hard to connect some of this stuff, is when that's a 0, notice how both of these end up being the same. So there's no need to do this twice. We can just get rid of those and kind of keep moving along. Now, the x-intercept is 2. Hold on a second, something's off here. So if I'm looking at my graph here, I want to make sure x-intercept. Where did I screw up here, guys? -2. Oh, I'm so sorry. Look at this. So what I did here, I'm noticing something's not right because this is not the same as this, right? And they should have been at this point. Here's where I made my mistake. On the bottom over here, I don't know why I put a -2 here. Because my a value in this problem was actually a 1/2. So that's what I should put on the bottom over here, and that's where I made my mistake. So 2 times 1/2, if you punch that in on your calculator, I'm sure you guys caught it and were just screaming at the screen. 1 times 1/2 is going to be a positive 1. So that's what's on the bottom here. So this is 1. And then over here, I would still have a 1 on the bottom. So 2 divided by 1 is 2. And look at that. We got the exact same answer doing it 2 different ways. Now, there's nothing that says you need to do it 2 different ways, but you want to have a plan in case you get one that didn't work out as nice as this. And that's it, guys. That's your test tomorrow. Thank you guys so much for watching the full video. I hope you found this helpful. Now go and practice. You have those practice tests there. I want you to go take advantage of that so that there's no surprises when you get to that test tomorrow. Thank you so much for watching. Have a great day.